Hi, Anusa and Sandeep. Mm, we'll be waiting for the next 2 to 3 minutes for others to join, or let's start with our.
Okay.
Okay, do you have any idea whether others are going to join?
Sandeep, can you share me your knife?
Hello. Hello, Thanuman, you can go ahead. I think Monica needs some time to join.
Okay, okay.
Yeah, actually, 4 people only in the class. I mean, remaining 2 people have removed, I think so. I'll talk to them and you can continue. Monica will join in the middle, okay?
Okay, okay,
Yeah,
sure.
yeah, go ahead. Yeah, thank you.
Okay. And okay, so let's start with our classes. And yesterday we have today we are going to do this particular cases, methods, more about the methods, overloading of the constructors, overloading of methods, static keyword, recursion, final keyword, and access controls. We have gone through the methods yesterday, that it can have different methods, and the parameters, a method or a function can have different parameters to it, or the same parameters. So what is overloading? In the beginning of the class, okay, we have taught you what is method overloading. So this is this was the constructor. Okay. Okay. See, during the first class or the demo class, I have told the polymorphism means getting processed in more than one form. That is one of the natures of the OOPS concept in Java. So what does polymorphism means? Suppose I have told you that a human is a class and can sing is a method. Male has inherited from the humans and female also inherited from humans. Now, can sing. Male can sing it in English and female can sing it in Hindi. That was the example that I have given for polymorphism. So now we have come to the one of the terms called function or overloading of methods. What does this mean? This means in Java, it is possible to define two or more methods within the same class. It needs to be within the same class that share the methods share the same name but their number of parameters are different. So this is called our method overloading or function overloading. This is a concept of polymorphism that already we have discussed the meaning of polymorphism. So in a class, two or more methods can have the same name, but the number of parameters inside them are different. So that is called overloading of methods. Now let's demonstrate one of the method overloading. Suppose I am declaring another class here. Overload demo. See, I'm writing something called void test sysout no parameters. Void test and a sysout a is plus a. Okay, then again I'm writing one more method, void test is int a int b. Okay, in overloading of function, I have written there should be a difference between the parameters per number of parameters, but the declaration type, even if the declaration type is different, then also even if the declaration type is different, then also we call them function or overloading methods. See, the declaration type means my declaration type was void here. Now I'm going to give it double test something double a and this out double a. Let's say as this is a double, I need to return a value of double type. That is already this a is double, so I'm returning it the square of the a. So this particular methods, you can see it has the same name, but the number of parameters between these two are different. Again, this among these three, the number of parameters are different, but here, as I've written the second line, even if the declaration type is different, then also it is called the function overloading, as long as your name of this particular method remains the same, and this overloading of methods are done in the same class. If the function in another class means was had the same name called test, then it is not going to be called as function overloading. It needs to be defined in the same class. So now let's call this overload method. I'm going to let's call this overload methods over demo is equal to new overload demo. Demo dot test demo dot test and demo dot test n comma 20 there was a double function, so let me define a double square equal to demo test 11.23 11.2 something 11 point something, I give 5 square. Let's find out. So if you can see the overload demo, this particular, when I'm calling this without the no parameters, then it will call this particular function, because this particular method, see, I've given no parameters, so the Java compiler will understand, okay, he's going to call the particular method with the no parameters. If I'm giving just one parameter that is of the int type, then it is going to call the next method. Now if I'm going to the third part, that test 10 comma 20, two parameters are there, so it is a two parameters, and when I'm passing a double value, then it is going to this particular method whose return type is double. So let's run this program. See, first when it is called no parameters, I have called, then it was a, that is 10, then it was a10 b20, it has been called this. Okay, let's do something here. Okay, let's do here, and let's format this, and let's do it again. See, now it looks good. So this is my overloading of methods declared within the same class. Okay, so are you clear with this? That uh, means, are you clear with what is function overloading?
Yes, sir.
Okay, okay. So now the thing is, yesterday we have, yeah, hello.
No, sir. I couldn't hear you. That's the reason I called. Yeah. I'm able to hear you now. Yeah.
Okay, so have you understood the function overloading of the methods?
Yes, sir. Yes, sir. I understood.
Okay. Now, do you remember that what we were doing with the box particular function that day? We have used the constructor. Okay, we have used the constructor. Now we can use the overloading of the constructor also. See, I had used this is my parameter type. Now I can use a default parameter box. Okay, this is the default constructor which have no parameters. So in this default constructor, what I do, I'm declaring the width as something 5, height as your 6, and depth is your 7. So you can see these two can be your, you can call this particular value as your overloading of the constructors. The constructors, two constructors have been defined. As we know, the constructor should have the same name of the class, but the parameters between these two are different. So you can say this is overloading of constructors. So let's do something here. Let me this. What's doing? I was doing this and see my program of the box now. Particular double weight height this. I'm calling the default constructor, which is giving a default value to 5, 6, 7. I'm declaring it. If I don't declare this default value, then automatically Java JVM declares this width, height, and depth as the default value, that is 0.0. But I'm explicitly giving this default constructor to explain the overloading of constructors. Now you can see it does not have any parameters, and it has your 3 parameters, that is width, height, and depth. Then I'm calculating the volume with the width, height, and depth, that I am calling it from this program. First, with this uh, with this object, I'm just calling the parameter, this box parameters with 10, 20, and 30. I'm calling this constructor. Now with the volume 1 that is written here, this is calling to that particular default constructor, and the default constructor is initializing the width as 5, height as 6, and depth as 7. So let's check. See, first one, this is the volume 1, volume box, sorry, volume, that is the volume box is mine. Particular with 10, 20, and 30, that is 6,000. And now I'm calling to the default constructor, which is giving me 5, 6, and 7, which is 210. So overloading of constructor, is it clear?
Yes, sir, it is clear.
Yeah.
Yes, sir.
Okay.
Yes, sir.
Sorry, Anusa, I can't
Yes,
hear
sir.
you. Okay.
Yes,
Okay.
sir, it's clear.
Okay. So now, okay. these two, they have many that they will check whether the memory reference or something is
Yeah,
same
equal
or
or
not.
not.
Okay, this is what I'm going to do a debug. I will teach you debug, how to debug the programs, and I'm going to show you something here. While executing, I can check the values without executing the next lines. I can just check the values. You can see the value is depth is 30, 20, width is something 10, and also the value is 30, 20, and it is same. But if you can check the memory reference or something here, it's something, you check it here, the wall, this particular wall, it's something called 156.15009, and you check it here. See, it's totally different. So it's not only checks all these values, it also checks this particular memory reference. See the example box, the memory reference is given here, and also the memory reference. These both are different. So it has come as a false. I will teach you how to debug the programs, means how to just go to the line without executing your next lines. I will teach you that what I did now and how to check the values. Okay, let's do another program called going to be this argument passing. Okay, there in Java or the computer language, argument in Java particularly, there are two types of argument that can be passed. Means two types of argument that can be passed. Means there are basically two types, not there are two ways that the arguments are passed. Pass means when I'm passing this particular arguments here, like I was doing the demo and I'm passing this particular 10, 10, 20 or 11.5 to this overload function. When I'm passing this 10 to here, there are two ways of passing it. The first way is called call by value. Let's check the call by value, what it actually does. It generally creates a copy of the argument that will be passed and then passes the copy of it. Suppose what I am saying, when I'm sending you this particular 10 here, so let's open the pen. Suppose for 10, this was my memory location. Okay, suppose 1, 2, 3, 4, 5, 6 is my memory location. When I'm passing it by call by value function, then what I am doing, I'm creating another copy with a different memory location. 1, 2, 3, 4, 5, 6, 7, and 8. Suppose this memory location, and it is 10, and I am passing this copy, means this particular copy. This is a copy of this particular parameter, and I am passing this. So while going here, while coming here, if you manipulate anything with the a, with the something, the parameter, so this particular reference this particular reference get manipulated. So when you come back to the main function, the main class from where I have called, okay, this does not affect this particular memory reference. So let's check one program, then it will be more clear to you what I'm saying. let's create another class. This is called test. Suppose I'm doing void main test void int I. I'm taking two. Now let's pass this from our main program. Test, test, B. New test. Now, suppose I'm declaring two variables int with the same name. I'm declaring it. 10 int k is equal to 20. New test. I'm calling to the functions. What was the function name? Called math test dot math. I'm passing this particular I and j and s. Let's copy the functionalities from here. In main. Let's check what does it print. See, when I'm passing this I and j here, as I told, the particular copy of this gets passed to the next class, that is the test. See, this has 10 and 20, another replica or the copy of it passed, but the original reference or the original values are not passed here. So even if you manipulate anything here, these are local to this method called math. The variables become local to this particular math. And this program, this first program, these variables are local to this. So these have the totally in the memory, they have totally different reference. Even if you manipulate anything as these are local to the math, so it does not affect from the in the main class from where you have called. This is called your something called met 10 and 20. It has printed, but here I have done the manipulation. There it was local 20 and 25, and this particular function is this particular way is called call by value. Now there is another way. Okay, suppose I want to pass the reference, memory reference. Then it is called the call by reference. Call by reference is that the reference of the argument is passed to the method, or okay, para as parameters. So let's take a program by call by reference. So let's modify this test, a bit of test. I need to pass the memory reference. So what happens when I pass the memory reference here? I'm going to pass this particular value, this particular memory reference. So what happens if I manipulate anything here? It's going to reflect in my main class also, because I am passing the reference, not the copy of particular uh, not the copy of this particular arguments or from the main class. So let's check the program. Okay, before that, let me tell you one thing. Before this, the difference between arguments and parameters before the call by reference. Your parameters, when you define something in a class like this, okay, in a method, when you are defining the variables in a class, inside a class, in a method, you are defining the variable. These are called in method definition. These are called parameters. But when you are passing any value, like from here I am passing this I and j, when I'm passing this I and j, this particular two values are called, when passing values to that particular method, is called arguments. So is it clear between the difference between the arguments and parameters? Both are different. When I'm passing it to that method is called argument, and when in method definition it is called parameters. Okay, so yeah, and let's do a program that I'm going to pass you then object. Int a comma b. Now I'm writing a constructor here, int a, int b. Let's make it ing. If I make it ing, I don't need to give the, let's make it, I don't need, when I'm using a different variable name, I do not use the this command because it's already different. So the Java, the compiler will automatically distinguish between them. If I had used something called a here, a and b, then I had to write this dot a equal to a, this dot b equal to b. Void math. I'm writing particular test. and o dot o obj object dot a equal to equal to a e plus I used maybe 10 of b math. Since I've given a parameter, let's make this call as your 10 comma 20 here. Let's delete this. Something let's do like this. I okay, only let's do like this. System this is before call, after call, okay. Sorry, this is also before call. It's a before call. Now I'm passing this particular values as something. What is my method is test math. I'm passing this particular object test. I'm particularly passing the reference. Value of I. Let's check what happens. Before call, it was 10:20. Okay. Then again, I'm calling. It is after call also 10:20. Can you tell me where is my mistake here? Anybody?
Sir, can you repeat the question again?
Do you understand what was the call by reference I wanted to do? Suppose the
Yes.
call by reference would have been your, I'm passing the value, passing this particular value, uh, 15 test I comma j. Okay, this has been passed here reference. Okay, this objects I am just incrementing this particular values, but my this particular uh, the I and j should have got changed. So why this has not got changed? Because this I and j are my variables. These are not the object that I'm passing, and I'm passing this particular copy, again particular copy of these variables. So let me check if I had passed something test comma before a test comma B and test comma A and test comma B. Let's check this. See now, before this, when I have called I and J, this test A and test B with this constructor, it is assigning the value 10 and 20. When I'm defining with the new, this is 10 and 20. With the help of this constructor, I'm initializing this particular values A and B, that is called 10 and 20. 10 and 20. So now I'm just calling again with this object what I have initialized 10 and 20. This object goes here and it does the manipulation of A and B. Then it again, this object is returned, and when I'm doing it as a test.a, a test.b, then it has come my 20 and 30. Have you understood this program?
Yes, sir.
Tejashwini, is it any confusion? Tejaswini, Sandeep, Anusha?
Yes, sir, I
No.
understood.
Okay, yeah. So let's go, let's check what is left again. Yes, this class. Okay, overloading, we have finished up to here. Now we go the methods also. Now we go to the static methods, or first let's go to the recursion. Okay, what does recursion means? Recursion means a method is called by itself. So inside this particular method, inside any of this particular method, like here math, you are calling that method again, that particular method again, this particular method from here, if you are calling it again, like call this math a comma b. Okay, just wait a minute. Math create method. Okay, something it is called, it's asking me that from here. Okay, I will show you a definition. If you call this particular method again from this particular value, that method a and b something, then it is called your recursion of this particular method. So let's do it. Let's call this particular method inside that particular method again. Let's do a program called recursion, or to find a factorial of a number. To find a factorial of a number. Let's do it here. Let's write a method, something called recursion method. Int fact and int n. Int result. I'm going to return this result. I need to write something called if n double equals to 1, then I need to return 1. Otherwise, for result, let me write it here. result equal to fact n minus 1 into n. See this particular method, I'm calling this particular method inside this particular method itself. So this is called the recursion method. So what this particularly this method does, let's check. Let's check with this logic. If I send 4, if the integer is 4, so let's check 4. Okay, I'm sending 4. Now if n double equal to 1, no, this will not go to 1, so it will go result, like result will be fact. Now 4 minus 1 3 into 4, this is your function. Now it goes to your second, again this fact is called with 3. Now when it is 3, this result, again it is not equal to 1, so this result is fact 2 into 3, this n. Now again when this n is equal to 2, it calls this particular function. Now the result will be fact 1 into 2. Now what happens when it has come already 1, so it will come to here, it will call, it will check, oh it's equal to 1, so I should return 1. It does not come here, it's already returned. Means return statement of a function, if you are returning it, that's the end of that particular method. Means that won't get, the below lines won't get executed. And again this return, if I have written it inside the if block, that means if you remember the continue statement I've written inside the if block, that conditional block, then it's returning the value, it won't get executed your below lines, so it's returning to that particular called method. Now when it has returned to me 1, so the value is here, the first will be 1 into 2, that's equal to 2. Now this has already come, that okay, this fact 2 has already become my 2, so it will be 2 into 3. From this is the result that is being returned here when it was fact 1, means when it was n is equal to 2. When n is equal to 2, this fact 1 has already become here, this value is 1. This fact 1 is your 1, so 1 into 2 2, so this particular function result is returning 2 here, so 2 something here, it is returning 2, so 2 into 3 is 6, so for this particular 3 it is returning 6, so 6 into 4 equal to 24, so the final result that is returned as 24. So let's do it from here. My first program, let me call to the factorial of a number. I'm just deleting it here. This particular f is equal to real no f dot factorial 4 is f dot fact 4. So let's check. See, it's 24. So is this particular recursion clear with you?
Excuse me, sir,
Yes,
I
sir.
have a doubt.
Yeah, come on, tell me.
Like the result of each function call is returned to the previous separate.
Yes, the previous value, because it's just waiting for the result to come. First it was fact 3. When it was something called fact 3,
Okay.
you are passing this particular value fact 3. So it is waiting what should be the fact 3 result. Okay, so it has passed again fact 2. Now what happens actually in a memory, every time a heap is created, like this, some heaps are created. Okay, this
It's
is
memory.
waiting for, yeah,
Okay.
in memory some of the heaps are created.
Mm-hmm.
Upon fact 3, it is waiting for the result of the fact 3. Then again another heap is created. Here it is waiting for the result of fact 2. Fact 2 again, it is created here. So fact 1. So this has been done here in this way. In memory a heap is created. So the value of this fact 1 has come 1. This value of fact 2, you can check. This particular value of fact 2 is has come to 6. Remember, 2 into 3, that is 6. That has come to 6. And this fact of 3 has come to your 24. Because you can check, if it was a fact 1, only this result. If you check only this result, fact 1 into 2, for this it will be 1, it will be here, and it will be into 2, the result will be 2. Okay, now you think in this way. Okay, this fact 2, okay, this fact 2, the result that has already been come, right here, fact result, you're waiting for this result, so it is 2. So 2 into 3 is 6. So fact 3 that I have called, this is the call from fact 3. This particular result is my fact 3, and this particular result is my fact 2. The call is done in this way. Is it clear?
So,
Okay. Now let's go this particular function called static methods. And I need to cover static methods and access controls. Okay, let's go to the static methods. So when you are defining anything called static, okay, when you are defining anything static, particular value static, if you remember that we are writing in the main class public static void main, so there is a keyword called static. Okay, static, if you define anything static, if you use or define any method, just wait a minute. Okay. Yes, where we were static. Okay. If you define any method or a block or a variable as static, that means before the object is created, object creating means with a new operator or referred, these are assigned in the memory. So till now we have seen, okay, whenever we are creating a particular object, then only this particular values of test or factorials of this memory is created. If you remember this, I've shown you in the box that width, depth, and height, a memory is created when you are using a new. Before that, nothing is there. But whenever you are writing static, before the object is created, these are referred to the memories. So suppose you declare a static variable. So what happens when you give a static variable? So it can be, see, there are types of static. When you are using the static keyword, it can be your static variables, static methods, and static blocks. What happens whenever you are defining a static variable? So a static variable, like when you are defining this particular object like a and b in the box, a and b in the box, and I'm defining two different objects like volume and volume 1. So two different memory allocations are done for this particular width, height, and depth. But when you are making anything here as a static, so the variables will occupy only one memory references. It won't refer to multiple memory locations. So what happens when a static variable, when a variable is defined static? This static, the static variable belongs to the class and not to the object. Remember, this belongs to the class, not to the object. Means you do not need an object to call that particular static variables. And static variables are initialized only once. Static variables, whenever you are writing or something, it will initialized only once at the start of the execution. Means even before your creation an object, this has already been initialized. Means before creating an object or the instance variable, this is already been initialized. As for this, a single copy, or you can say memory reference, is shared by all the instances or objects by the class. Okay, and already you do not need any variables, means do not need any objects to call these static variables. Let's do a simple program. Let's do it something here. Example. Let's do this static keyword. Class, you have this particular void. Let me do something called initialize, a simple, not static one. Int count equal to int count equal to 0. This is not a static one. It's not static. And I'm going with a method void counter. Okay, count plus 1. So what it is saying? Okay, sorry. Create method counter. What is wrong here? Zero. Okay, sorry. The mistake what I'm doing here. See, I'm writing this inside particular method. It should have been written inside your particular class. So this was my mistake. So I'm writing it here. Writing it here. Suppose this example. Let's make it a constructor then. Int count equal to 0, not a static. I'm making inside a constructor only. Example, count plus this out this count, and I am calling this particular example C1 equal to new example. Tell me what will be printed here, or something. If I do something 3 times, counting 1, counting, suppose I'm going 3 times, what's going to be printed here? I have not used a static. So every time when I have not used a static, I have not used a static here. So what's going to be printed here? Means when I'm creating a new, this variable is getting initialized in the memory when only new. Then tell me what should be the static variable here, because means sorry, what will be the example? Like, see, I've given static variables. A single copy of memory reference is shared by all the instances of the class, but it is not static. So a shared instance is not being shared by all the objects. These are 3 objects. So a single copy. Whenever you're creating a different memory location has been created, like count equal to 0 for C2, count equal to 0 for C3, also count equal to 0. So tell me what's the result is going to be here. Anyone? Anusha or Monica, Sandeep, Tejashwani? What should be the result of this particular value?
Is it 1?
Yeah, there will be 3 variables. So
Three times 1.
okay, yes,
Sorry.
correct. Yeah,
Is
3
it
times it is
1,
going to be 1.
1, 2, and 3, or 1, 1, 1? Okay.
1, 1, 1, because this is not a static variable. It's different. Like whenever you are doing a count, there are Yeah, 3 memory references with count 0 are created. 1, 2, 3. 3 memory references with count and all will be 0. So when you are creating an object, that 3 different objects, 3 different memory locations are created for this count with count equal to 0. So for this, as the 3 memory uh, references are there, so count plus plus is 3 times 1. Okay, so but let us check if I had given it something static int. Remember, in this case, only one memory location is shared by all these 3. So if it is increased in that particular, it is only one memory location. When you are giving a static, only one memory location, and it will be shared as much as how many objects you are going to create, it is going to share that. So whenever I am increasing this, okay, it's going to increase in this particular memory references, and the objects are going to refer a single memory references in the static. So I'm going to do it as, see, now you check, it is 1, 2, 3. So is it clear between the static and this?
Yes, sir.
Okay, why do you use static? Can you tell me? Like I'm giving you, suppose you have an class of student. Suppose you had a class of student here. Student. Okay, and you had something called int roll number, int roll, string name, and string college. Okay, the thing is, when you write this, remember the roll number of every student is going to be different. It's unique. The name is different. Name can be different or maybe same. That is least possibility. But remember, if you are writing it in a single college, the college will be always one to this particular student, means class of student inside the same university or same college, or you can say the university here. So I can make it static. So for every time, for each student with a different roll number and the different name can have the same college because they belong to the same college. Like any college, you can give the name. So it will always contain a single references. Okay. And any questions till now with this particular static variable? Anyone?
No, sir.
No, sir.
Okay. So the thing is, we have gone the things we
So
in the
this
next
is
class.
uh
Yeah, it is only the static variable that I've taught. Now there will
okay.
be static method,
Okay.
static block, okay, and the fine. This is I'm going to do in the next class, and access control, and plus I will start with the inheritance. Okay, I will start in the next class. Yeah,
Sir,
hello.
tomorrow we have a grad walk, so I may not attend the class. Me and Sandeep, we both have the grad walk ceremony tomorrow, so it
Okay,
would
maybe
be.
there won't.
Even I have, sir. I'm sorry. This is Monica. Even I have the class. I have the grad works.
Yeah, but I think that we have. We will means
Yeah,
for me it's
we will
Saturday and
discuss
Sunday.
further on this and we'll let you know Monica, Anusha and Sandeep, and I'll update Tanuman also on this.
Okay.
Yeah,
Okay.
yeah.
Yeah.
Okay.
And I'll
Yeah.
share the recording and
Mm-hmm.
yeah, bye all of you.
Yeah. Bye.
Yeah. Bye bye.
Bye.